All right, we're going to go through these. So the first one is what type of shape? A rose, and we know this because there's a number in between the trig function and the theta. How many petals does this rose have? 3 petals. Odd, you keep it. Even, you double. What's the length of each petal? 6. So the easiest way was to find where one, and symmetry. Abe, head up. What's your symmetry? It's to the pi over 2 line, right? Or former y-axis. So the easiest way to find your first petal is to plug in the radius as the length of the petal. So it's going to be 6 in this case. 6 equals 6 sine of 3 theta. And then I would divide both sides by 6. This exact step will happen every single time you start this process. You'll end up with 1 equals whatever's there, right? Because you're always setting them equal to each other. So then I look for where sine is 1, and that happens at pi over 2. So again, that answer would always be the same. But now it's that pi over 2 equals 3 theta. That's where it changes. So I divide by 3 or multiply by a third, and I get pi is equal to pi over 6. So my radius is 6 at pi over 6, which means a petal exists here, 6. And then because it's symmetric to the y-axis, I know that happens on the other over 6 on the left-hand side. So my other petal here, or second petal, is here. And then there's symmetry along the y-axis, so the only other spot for it to be is on the bottom, right? If there's 2 on the top, 1 on the bottom. So I assume that it is here, and I would draw it, and you're done. If you know what you're doing with a rose, that's as easy as it is. If you're unsure, then you're literally plugging in points trying to find it. So if I were to plug in this bottom angle, I would get r equals 6 sine 3 times 3 pi over 2. I'd get 6 times the sine of 3, or 9 pi over 2. 9 pi over 2 is 4 1/2. That means I'm going around my circle twice and ending at the top where sine is 1, and I'd get 6 times 1, which is 6. So that's the way you can confirm that loop. But really, if you just know what you're doing with a rose, you're maybe just finding 1 or maybe 2 points and you're done. Okay, you're plugging in the r. You maybe find a second point and then you're done. Did you get -6?
Yeah. No, I got
so it should be negative, right? Because if it's what you got, 6 sine 3 pi over 2, you plugged in?
Yeah.
So the sine at 3 pi over 2 is -1. It's down here. So it would be 6 times -1, and that's -6. So this is my angle, but I go the opposite direction, which still puts your point there.
Oh, I was thought the changed angle was like your new angle.
No. Yeah.
Okay.
You're welcome.
How would you know to put the pedal going down? Like,
So,
plugging the point in?
I mean, with 3 petals or an odd number of petals, there's always part going up and part going down. So once you find the one on the right at pi over 6 and you know to reflect it because it's symmetric to the pi over 2, the only other place it can go is down. If I put it over here, it would reflect over there. That's 4 petals, so that doesn't work. Does that make sense?
Yeah.
It's got to be an odd number of petals, and then it means that if there's 2 at the top, there has to be the 1 at the bottom. This could be flipped, like there could be 1 at top and 2 at the bottom, so it could vary which direction it goes. But if it's 3 and it's sine, it has to look like that. If it was 3 and cosine, it'd be rotated so that it's symmetric to the polar axis. So there'd be 1 on the right and 1 on the top, 1 on the bottom, like that. All right, second one says, again, same thing, sketch it. So this time you have a choice. You can either distribute at the beginning or distribute after. Either way, you should be able to identify this as what kind of graph? Limison, because you have a plus or minus there. So if I make this r equals 3 minus 3 cosine theta, then my A is what? 3. My B is also 3. A over B, which would be 1, is what kind of limison? A heart-shaped or a cardioid. And what kind of symmetry does it have? What? Nope. Polar axis. This one's symmetric to the polar axis because it's cosine. So I'm going to find the points at the top. Remember that the limicons are the ones you plug in the most points. So I'm going to plug in 5 points. I'm going to plug in 0. I'm going to plug in pi over 2 and pi. And then you can literally pick one from each of the top quadrants. It doesn't matter which one. I tend to pick pi over 4 just to be consistent, but it really doesn't matter. If you really wanted to like figure out like where it would give you, well, this time it doesn't matter because it's odd. But if there was a whole number on the front of cosine that was an even number, so you wanted to find where cosine was a half to make it like an even number, that works too. So you can try to pick whatever you want. But if you always stick with the same things, then at least you remember those points, it might make it a little bit easier. So I'm going to plug in 0. So if r equals 3 minus 3 cosine at 0, the cosine at 0 would be 1. So 3 minus 3 times 1 is 3 minus 3, which is 0. So 0, 0 is a coordinate point. And then I'd go to the next one. So r equals 3 minus 3 cosine pi over 4. And the coordinate point there is root 2 over 2 and root 2 over 2. So the cosine is root 2 over 2. We're going to approximate root 2 to be 1.4. 1.4 divided by 2 is 0.7. So 3 times 0.7 would be 2.1, and 3 minus 2.1 is 0.9. 0.9 pi over 4 is that coordinate point. Then I go to the next one, so I'm going to plug in pi over 2. 3 minus 3 cosine pi over 2. The cosine at pi over 2 is 0. 3 minus 0 is 3. So 3 pi over 2. So at pi over 2, you're at 3. And then I would go to 4. 3 pi over 4. Coordinate point there is negative root 2 over 2. So we just said that this is a 0.7. 3 times a negative, minus 3 times a negative 0.7 means this is plus 2.1, and that's 5.1. Yeah. Nope. Not for that part. Not for this part, no. And then the last one is pi. So r equals 3 minus 3 cosine at pi. The cosine at pi is negative 1. This becomes 3 plus 3, which is 6. And then because it's symmetric to the polar axis, we're going to flip all of those points onto the other side. So the other over 4 is just past 5. At pi over 2, it's 3. So at 3 pi over 2, it's 3. And this was 0.9. So the other pi over 4, which is here, like a 0.9. And then I know it's a heart. So I make it like dip in the middle. And it should look something like that. All right, so I said it yesterday, but I'll say it again, like on your test. Right now, I think I'm going to work on the timing, but right now I think I have 2 graphs on there. One will definitely be a limison, and then you'll have to classify it as the heart, the loop, the convex, or the, what am I missing? Or the dimpled. And then you're going to get either a rose or a lemniscate or a circle for that last one. It just won't be like r equals 3. It's not going to be that easy of a circle, but it will be one of those, okay? All right, so our last section that we are going to cover in your textbook is 10.1, and it is 3-dimensional coordinate system. So if you are a senior, this is the last section that you will take notes on. This is, obviously a little bit different than what we're doing, but some of it has overlap with what we have done before. So this is not a horrible section. That's the good news. We are basically learning how to plot a 3-dimensional point. So that point is going to get an x, a y, and a z coordinate to it. Okay. It exists. You're finding it in space because it has a 3rd dimension. And it says the geometry of this 3-dimensional model is called solid analytical geometry. So this is the start of analytical. If you could picture, and this is the hardest part about this lesson, is to teach something on a 3-dimensional on a 2-dimensional surface, right? But if you could picture, if you had your normal xy, or your normal x-axis, which runs side to side, your normal y-axis, which runs up and down, now you've got something that's going forward and back, which can be your z-axis. What's confusing is those can rotate in any direction, so you can actually spin it around, okay? So if you were to look at this graph that's here, you want to pay attention to where the letters are. Like you see that x is at the front. So this would be, my x is moving forward and back on this one. The y is moving left to right, and the z is moving up or down. Those will be labeled so that you know which axis that you're using, okay? But it works the same as if you think about every other coordinate plane. If my x is positive, I move towards the x. So this would be my positive x side, and back here what's hidden by the other plane would be my negative x side. So you move towards the letter If it's positive, you move away from it if it's negative. If I had a positive y, I'd move it in that direction. If I had a positive z, I'd move it in that direction. And then if not, I move it in the other direction. Okay? So again, it will label it, and then you'll know which direction it goes. These cubes are called octants. There are 8 of them. So there's 8 quadrants that are called octants on a three-dimensional coordinate system. So if you could picture like a 2x2 Rubik's Cube, right? This is kind of what it would look like in 3 dimensions. The first octant is the one in which all 3 coordinates are positive. So our first quadrant, or first octant, would be where there's a positive x, a positive y, and a positive z. You don't really need to know this. Like, I'm not going to question you on that. But you need to know how to plot a point on this system. And your ordered triple, instead of a pair now, is going to be x, then y, then z, always in that order. So example 1 says, determine which is the point 2, -3, 3 in the coordinate plane below. So again, note the variables and their locations. This is my x, this is my y, and this is my z. So if the first term or first number is 2, that means I'm going towards the x-axis 2 spaces. So I would start at the origin and I would move towards the x2 because it's a positive 2. Then -3 is your y. Your y is over here. So if it was positive, I would move to the right. But because it's negative, I'm moving away from it. So I'm going left 3. And then the z is the last one, and the z is +3. My z is up here, which means if it's positive, I move up. If it was negative, I'd move down. I'd go up 3 spaces, and this is the coordinate that would be to -3, 3. So positive moves towards that variable, negative moves away from it. Pay attention to the location on your variables. Sometimes the x is at the front like that. Sometimes it swings around to be at the side. All right, now you're going to plot each point. So this is, again, where it gets kind of difficult because people try to go directly like left or right of a point. But this is an angled line. So you are moving, and you're going to be moving parallel to that line instead of exactly 1 unit away. So if I wanted to plot -1, 3, and 4, my -1 is my x. So I would start at 0, 0. I'm going to go back 1. Then my y is 3, and my y is to the right. But instead of just going to where it's 3 and plotting a point, that's not y is 3. This is tilted. So I'm going from where I stopped on my x. I move parallel to the y-axis about the same distance that this would be. So it doesn't have to be perfect, but it'd be like 1, 2, 3, and that is where your x would be -1, your y would be 3. And then the last one is where z is 4. Again, z is not vertical. This is kind of lean forward. So you have to approximate 1, 2, 3, 4. I would just say watch your little scoops and keep them about the same distance. This is not a perfect answer. Not every single person's point is going to line up exactly the same, but they should be around the same location. All right, so D is +1. I'd start at 0. I'd move forward 1. Then +3, I move towards the y, 1, 2, 3. And then +2, I go up 1, 2. And D would, again, be around there. It's not a perfect science. It would be around there. And the last one is E. I'd move forward 2. This time I'm going left 1. And I'm going up 1, 2, 3, 4. And E would be approximately there. To be honest, this is like the hardest concept because it's abstract. The rest of the stuff is like formulas and plugging in, which most of it you already know. So as long as you can grasp the movement on this graph, you should be fine. All right, then we get to distance and midpoint. So if I want to find the distance between two three-dimensional, or 3 coordinate points, or the midpoint between those 3-dimensional points, I literally take the formulas you already know, but I add on for z. So the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And the midpoint formula, I do the same as I always do with my x's and y's. Add the 2 x's, divide by 2, add the 2 y's, divide by 2, and now I add the 2 z's and divide by 2. All right, so this one just says find the distance and the midpoint of the segment between 0, 1, 3, and 1, 4, negative 2. So the distance would be the square root of, and it doesn't matter which ones I make the 1s and which ones I make the 2s, as long as you're consistent between the points. So this would be 1 minus 0 squared plus 4 minus 1 squared plus negative 2 minus 3 squared. Square root of 1 squared plus 3 squared plus negative 5 squared, which is 1 plus 9 plus 25, 10 plus 25, which is the square root of 35. With every square root, you want to make sure that you can't break that down. 35 is just 5 and 7, nothing repeats, so it's going to stay as is for your distance. The midpoint, I'm going to add the 2 x's, divide by 2, add the 2 y's, divide by 2, add the 2 z's, divide by 2. So I get 1 half, I get 5 halves, and I get 1 half. Again, with fractions, you want to simplify them. You don't need to turn these into mixed numbers. You can leave them like that. Easy stuff, right? You're literally just adding on another variable. Okay, and then the last thing is a sphere. So we're making a 3-dimensional circle, which is a sphere, okay? The equation for a circle, the standard equation for a circle was x minus h squared plus y minus k squared equals r squared. So now we've basically just taken and added on a third variable, right? And this comes, like, we get this from the distance between the points. That's where it comes from. Now we're using the distance formula from the sphere to get to the standard form of a sphere, is this. X minus h squared plus y minus k squared plus z minus j. Don't ask me why j comes after h and k. It makes no sense, but it's the way it's done. Equals r squared. So your center is hkj. And your radius is still r. All right, so this says find the standard equation of the sphere with a center 2, negative 4, negative 5, and radius 3. So this is my h, this is my k, this is my j, and this is my r. X minus h squared plus y minus k squared plus z minus j squared equals r squared. So x minus 2 squared plus y minus a negative 4 becomes y plus 4 squared plus z minus a negative 5 becomes z plus 5 squared equals 3 squared, or 9. So just remember that it's going to change your signs. This one is now the reverse. You get an equation and you're going to be asked to pull the information from it, okay? But this is not in standard form. How do we get equations into standard form? Complete the square. Not once, not twice, but 3 times, okay? Just when you thought it couldn't get any more fun. The good news is that I like go pretty light on these. There's not going to be like a coefficient in front of your terms, so it's not so bad. But we're going to group them. So we're going to group the x squared and the 4x. We're going to leave this space because we're going to fill it in. We're going to group the y squared and the negative 2y. And we're going to group the z squared and the positive 8z. And bump the 10 to the other side so it becomes negative 10. So then I find the third term 3 times. I'm going to take the 4, divide it by 2. That's 2. Square it. It's 4. I add the 4 here. I have to add the 4 to the other side of the equal sign to balance the equation. Repeat that for the y's. 2 divided by 2 is 1. 1 squared is 1. Add the 1 here. Add the 1 here. Last time, take the 8, divide it by 2, that's 4. Square it, it's 16. Add the 16 here. Add the 16 here. Good so far. Okay, now we factor. Square root the first term, square root the last term, take the sign from the middle, put it in the parentheses and square it. Repeat that for the y, square root the first term, square root the last term. This time the sign is negative, so we take the sign from the negative, or take the negative from the middle, put it in parentheses and square it. Last time for the z, square root the first term, square root the last term, take the sign from the middle, put it in parentheses and square it. And then negative 10 plus 4 is negative 6. Negative 6 plus 1 is negative 5. Negative 5 plus 16 is positive 11. So now I'm in standard form, but it asks for the center and the radius. So my center is what?
-2, 1, -4.
Good. And my radius? Good. Questions?